this week, we will cover the loads and stresses acting on aerospace structures. You have already seen examples of typical aerospace structures. And now you will learn to assess design and structures in terms of loads and stresses. The first step we need to take to understand loads and stresses is to investigate which external loads are acting on the airframe. Looking at airframes, we need to identify all the external loads acting on it and identify the type of loading. Is it a concentrated or a distributed load? And is a load static or dynamic? Let's first take a look at an aircraft in steady-state flight. You can make a simple representation of the loads acting on the aircraft by 4 concentrated loads in equilibrium. The lift generated is equal in magnitude and opposite in direction compared to the weight of the aircraft. The same is true for the thrust generated by the engine and the drag, which are also in equilibrium. Here we assume that all the forces are acting in the center of gravity of the airplane and that the airplane can be represented by a single point. When we need to assess structures and materials, this representation, however, doesn't work. What you see here is a more representative illustration of the external loads on the aircraft. The lift is generated by the wings, not by the fuselage, while the weight is mostly dictated by the fuselage. These loads are not concentrated loads, but are distributed over surfaces. For instance, the lift is distributed over the whole wing. The thrust is locally introduced by the engines, while the drag, which is not drawn on the picture here, not to make it too complex, is generated by the whole aircraft. Keeping in mind that this aircraft is in a steady-state flight, we are looking at a structure in equilibrium. If we would again look at equilibrium, the point of application of the forces is also very important. Hence, when looking at equilibrium, we need to assess not only the magnitude and direction of the load, but also the point of application. Since the point of application is different for the different forces acting on the structures, they are not aligned, and my structure needs to provide a load path to transfer the loads. The load path links the application of one applied force to the forces elsewhere that provide equilibrium with the applied force. When assessing a structure, we don't only look at a steady-state flight. We need to look at all the typical load cases, and with our structure provide load paths that can carry and transfer all these loads. Typical load cases that are applied to the airframe include maneuvers, gust loads, pressurization of the fuselage, landing, etc. And as discussed before, these loads can be concentrated or distributed. The thrust of the engine can be approximated with a concentrated load at the engine, while the lift force on the wings is acting over the whole surface. So to summarize, for assessment of loads and stresses in the airframe, it is important to identify all the external loads acting on the airframe and to identify their magnitude, direction, and point of application.